Welcome, ladies and gentlemen. Today we're going to talk about natural logs. So you guys are going to need notes, a pen and or pencil, and a calculator, please. All right, let's get this started with special types of logs. So make sure you have this written down, please. Now, a common log, which we've talked about already, is base 10, which is our log button on our calculator. Okay, now a natural log is base E. So when we say this, it's going to be log of base E, but we are going to write it like this, ln. So these two things mean the same thing. So make sure you get this in your notes, okay? But the most thing that we're going to be using here is ln. That's what we're going to use for natural log. All right. Now an example here, this is what we're going to put into our calculator. Alright, ln, so you're going to have to find that button on your calculator. It's usually in the same place that E is. So we've already used E, so you want to find that ln button on your calculator. When you type that in, you get approximately 1.79. Now, ln of 6 is same as saying the log of E is 6. So these are the same exact thing. Now if I wanted to rewrite this, I would have E to the 1.79 is approximately 6. All right, moving on. Make sure you're getting all these examples in your notes today, please, ladies and gentlemen. So natural logs and working with E. If we want to rewrite this in log form, this is what we're going to do. Whenever we have E, instead of writing log base E, we're just going to write ln. So we're going to have the ln. Now remember, our goal is to get our exponent all by itself. So it's going to be ln of 54.6 equals 4. So that's how we rewrite this exponential into log form. Now this next one we're going to rewrite in exponential form. So my ln is going to turn into E, and E is my base. So it's going to be E. My exponent's always what's over here by itself, so it's E to the 2.48 equals 12. All right, moving on. Here we go. Now, if we're going to evaluate natural logs without our calculator, we're going to do it very similarly to what we've already done. But now we're working with E, okay? So if we look at this, if it helps, if you need to rewrite it in log form, you can. So if you want to write it as log E1 equals X, you can do that if it's going to help you. But whenever we're working with natural log, our base is E. So if I rewrite this, it's E to the X power equals 1. Well, anything to what power equals 1? 0. So it's going to be E to the 0 equals 1. So our X here equals 0. Can do the same thing for this one over here. Now whenever I'm working with ln, that's my base number. So it's E to the X power equals E. Well, if it's going to equal the same thing, my X is going to have to equal 1. E to the first power is just going to equal E. Come down here, rewrite this one. E to the X power equals E squared. Well, we want E squared to equal E squared, so X equals 2. And our last example here, remember we're working with ln, so my base number is going to be E, so I have E to the X equals E to the negative 3. So if I wanted to equal E to the negative 3, X has to equal negative 3. All right, ladies and gentlemen, moving on to our last example. Please make sure you had all these ones written down. And we're going to do one graph, and then we are done for the day. So when we have this graph here, we are going to set this up. This is the inverse of E. So just like we were doing logs in exponential form earlier, we need to rewrite this exponentially. That's the first thing we need to do. So I have y equals the natural log of x plus 1. Now my base number here, remember, because I'm working with ln, is e. So I have e. Now my y is by itself, so that's my exponent. So the y equals x plus 1. Now it's very important, I've been noticing a lot of people, when you solve this for x, we're subtracting 1 on both sides. You keep the e to the y power by itself, and then behind it you're going to put minus 1 equals x. Now since x is the one that we just solved for, ladies and gentlemen, we have to pick our y values. So for y values, we're going to go negative 2 to 2. Alright, now we're just going to type this into our calculator. So when you type this in your calculator, you're going to put in e to the negative 2 minus 1, which is approximately negative 0.86. And if you plug in negative 1, you're going to get negative 0.63. 0, you're going to get negative, 0, you're going to get 0. If you type in 1, you're going to get approximately 1.72. And if you type in 2, you're going to get 6.39. Okay, so you're just plugging in these values for y. So you have to make sure you know where your E button is, which we've already used. And now we can go ahead and start graphing. First thing we have to do, ladies and gentlemen, we're still going to have an asymptote. And that's right here. It's whatever is being added or subtracted at the end. So my asymptote, and since I solved for x, it's going to be x equals negative 1. So put that on our graph right away, because we know we can't pass that. So x equals negative 1. And now we can go ahead and graph. So I have negative 0.86, negative 2, so right there, negative 6.3, negative 1, 0, 0, 1.721, so right there, 6.392, so right there. Remember to put arrows on both sides of your graph, please. And there's our graph. So last thing we have to make sure we know, domain and range. So domain on this one, we have restrictions. We have our asymptote. We can never cross negative 1. So for our domain, it's x such that x has to be greater than negative 1. And for our range, that's our y value. We got to pick whatever we want. Whenever we get to pick whatever we want, it's going to be all real numbers. All right, wonderful people. That is all I have for you today. Go out and enjoy the day, and I'll be seeing you later. Bye.